Hello and a warm welcome to the AI with Arun show. Imagine a world where the mysteries of the deep ocean are unlocked not by human hands, but by intelligent machines. A world where search and rescue missions are expedited by unparalleled speed and accuracy, and underwater defense is revolutionized by autonomous capabilities. This is not science fiction. It is the rapidly evolving reality of AI integration in submarines. And that's exactly what we're going to talk about in this video. So, in this episode, we'll dive into how AI is transforming these incredible vessels across military, scientific, and commercial applications. So, in military applications, how is AI enabling autonomous combat, enhancing detection, and refining weapon systems? In scientific research, what is the role of AI in deep ocean exploration, geological monitoring, and advanced sensor integration? In commercial use, AI's impact on oil and gas operations, search and rescue, and infra protection, and the cross-platform technologies, where the underlying communication and navigation systems. And we'll also look at the future development and challenges. So let's begin with the military domain, where AI is fundamentally changing underwater warfare. The most significant development we are seeing is the rise of fully autonomous underwater vehicles, or AUVs, designed specifically for combat missions. Now, a prime example of this revolutionary shift is the Royal Navy's Extra Large Unmanned Underwater Vehicle, or XUUV. This is a major breakthrough in autonomous underwater operations. Built by MSUBs of Plymouth under a £2.5 million contract with the Ministry of Defense, this impressive 9-ton craft can operate autonomously for up to 3 months, ranging as far as 3,000 miles from its home base. Its movements and actions are entirely governed by AI, showcasing a level of independence previously unimaginable for such critical missions. Beyond autonomous operations, AI is significantly enhancing our ability to detect and track submarines, leading to a new era in anti submarine warfare. One key area is sonar analysis. Traditionally, sonar relies on interpreting acoustic signals, which can be incredibly complex. AI algorithms are transforming this by processing acoustic clues from multiple scattered sensors. Think of it like this: just as the Shazam app can identify a song, modern systems like those developed by Thales use deep learning algorithms to recognize the unique song or the acoustic signature of a specific submarine. This makes detection much faster and more accurate. Another powerful detection method is magnetic detection. The US Navy's Magneto system, a $1 million project, uses AI to identify submarines by sensing how they distort the Earth's magnetic field. This technology has drastically improved detection accuracy while significantly reducing false alarms, which are a major challenge in the older systems. Finally, we have multi domain integration. The AUKUS Alliance, which stands for Australia, UK, and US Alliance, which is a critical defense partnership. As you can imagine, between Australia, the UK, and the US is a leading example. This alliance leverages AI to help crew members track enemy submarines with greater speed and accuracy by processing vast amounts of sonar data through advanced algorithms. This collaborative approach demonstrates the strategic importance of AI in modern naval defense. Now, AI is also being integrated into advanced weapon systems, particularly in torpedo guidance. This is one of the most sophisticated military applications that we are seeing. Now, consider the advancements made by the Chinese researchers. They have developed AI powered torpedoes that boast an impressive 92.2% success rate in distinguishing real submarines from the decoys. To put that into perspective, older legacy systems often achieved only about 61% accuracy. So there is a significant leap forward. These advanced systems utilize complex techniques such as physics informed convolutional neural networks, CNNs, and generative adversarial networks, or GANs. Without getting too technical, these are powerful AI models that can process sonar data to identify authentic targets even when faced with sophisticated countermeasures like acoustic holograms or bubble trails designed to fool traditional systems. On the US side, the Navy's CLAWS project, which stands for Autonomous Lethal Weapons System, has allocated $26 million towards developing autonomous underwater weapon systems that could operate without direct human intervention. This highlights the increasing move towards autonomous combat capabilities. Now let's transition to scientific application. AI-powered submarines are revolutionizing deep ocean exploration. They are not your typical manned submarine submersibles. They are highly autonomous data collection platforms. So AI-powered scientific submarines can now operate for extended periods, even months, independently, collecting detailed data about marine environments. They do this using advanced sensors and imaging systems. Critically, these systems employ machine learning to identify patterns within the vast amounts of oceanographic data they gather, making research missions far more efficient. One fascinating application is marine life classification. Research submarines are equipped with lightweight AI inference models that can classify marine species locally, right there underwater. Now, this is a game changer because instead of having to transmit massive image files back to the surface vessels, they only send the classification outcomes. This drastically reduces the data volume, making real time analysis and long duration missions much more feasible. Beyond marine science, scientific AUVs have fundamentally transformed marine geoscience. Their ability to operate autonomously in some of the most extreme environments on Earth, from the deepest hydrothermal vents to beneath polar ice sheets, provides unparalleled access for research. They provide significantly higher resolution seafloor mapping data than what can be achieved from surface vessels, especially in deep water environments where traditional methods are less effective. The primary applications of these AI enhanced AUVs in marine geoscience include studying submarine volcanism and hydrothermal vents, mapping and monitoring features where low temperature fluids escape from the seafloor, mapping benthic habitats, which are the organisms living on the seafloor in both shallow and deep waters, and generally mapping the intricate morphological features of the seafloor itself. Crucially, AI enhanced submarines are playing an increasingly vital role in climate change monitoring. They provide critical insights into ocean current patterns, how the ocean absorbs carbon, and changes in marine biodiversity, all of which are essential for understanding and addressing global climate shifts. Now, let's explore the commercial realm, starting with the oil and gas industry, where AI is bringing about significant operational efficiencies. In this sector, resident AUVs are becoming commonplace. These are autonomous underwater vehicles that can operate continuously for months or even years, monitoring subsea production equipment without requiring human intervention. This greatly reduces the need for expensive and often hazardous manned inspections. Companies like Lockheed Martin and Saab CI are at the forefront of developing these resident AUVs for inspection and maintenance. These AI powered submersibles can inspect platforms and pipelines up to 4 times faster than traditional human piloted, remotely operated vehicles or ROVs. This translates directly to cost savings and increased operational uptime. Furthermore, AI algorithms are being used to analyze sensor data collected from this equipment to predict failure even before they occur. This predictive analysis capability is incredibly valuable for major oil companies as it significantly reduces downtime and maintenance costs, relying for proactive rather than reactive repairs. But beyond industrial applications, AI is making a profound difference in a field where every second counts: search and rescue operations. A revolutionary example is the Aqua Eye technology. This AI powered sonar device combines traditional sonar capabilities with AI to locate human bodies even in challenging murky waters. The impact is immense. This system can scan an impressive 8,000 square meters of water in just 5 minutes with a detection range of 50 meters. This dramatically reduces search time from hours to mere minutes, significantly increasing the chances of successful rescues. Fire departments and rescue organizations are increasingly deploying these AI powered systems. These systems can accurately distinguish between human bodies and other underwater objects, which is crucial for efficient operations. This not only improves the success rate of rescues, but also reduces the risks faced by human rescue personnel who would otherwise be undertaking these dangerous searches. AI-powered submarines are also vital for infrastructure protection and establishing robust underwater communications network. Consider critical maritime infrastructure like subsea cables and pipelines. AI-powered platforms such as Windward's Critical Maritime Infrastructure Protection Tool often comprehensive monitoring of these essential assets. They use behavioral pattern detection to identify and mitigate risks before they can cause disruptions to vital global communication and energy flows. Underwater communication is inherently challenging. AI systems are optimizing this by dynamically adjusting transmission parameters like modulation schemes, packet length, and transmission power. This allows for optimized energy consumption. For example, when monitoring a rare species, low power BPSK modulation might be used, but for common species detection, a higher efficiency QPSK modulation can be employed. This adaptability ensures efficient data transfer based on the specific needs of the mission. Furthermore, advanced AI algorithms are enabling underwater optical communication systems. These systems offer unprecedented bandwidth ranging from the 1 to 10 megabits per second at distance up to 200 meters. When combined with acoustic technology, these optical systems allow for untethered operations with highly reliable data transmission, opening up new possibilities for long duration and complex missions. Now, precise navigation and comprehensive sensor integration are fundamental to all submarine operations, and AI is revolutionizing both. Modern submarines now use AI driven visual navigation solutions for incredibly precise positioning. These AI systems complement traditional inertial navigation systems, especially in scenarios where GPS is unavailable, such as at the periscope depth. Machine learning algorithms empower submarines to plan optimal routes autonomously, effectively avoiding obstacles and potential threats. These systems are continuously adapting to changing underwater conditions, which not only optimizes mission effectiveness, but also significantly enhances safety. One of AI's greatest strengths is its ability to integrate and interpret data from multiple sensor types simultaneously. AI systems combine information from sonar, optical cameras, thermal imaging, and magnetic sensors to create a truly comprehensive underwater situational awareness. This vision approach dramatically reduces or improves detection accuracy and drastically reduces false alarms. Finally, AI algorithms are processing vast amounts of the sensor data in real time. This allows for immediate decision making without the need for surface communication, which is absolutely essential for autonomous operations, particularly in contested or sensitive underwater environments. Now, looking to the future, AI integration in submarines promises even more groundbreaking advancements, but also presents significant challenges that we must address. One exciting development is the exploration of quantum enhanced AI. The AUKUS, as we had mentioned earlier, which stands for Australia, UK, US nations, in particular, are investigating the integration of quantum technologies with AI for submarine detection and anti submarine warfare. This combination holds the promise of truly significant advantages in naval warfare, especially in strategic areas like the US China contest across the Pacific. Another area of intense research is swarm coordination. AI enables multiple submarines to operate as coordinated swarms, sharing information and autonomously coordinating their actions. This capability multiplies the effectiveness of submarine operations while simultaneously reducing the vulnerability of individual vessels by distributing risks and capabilities. However, the deployment of AI in submarine operations also raised critical safety concerns. The reliability of these systems in life threatening situations is paramount. Researchers are emphasizing the urgent need for robust verification methods and fail safe mechanisms to ensure these autonomous systems operate as intended and can be controlled effectively. Finally, a persistent challenge is data quality. AI systems rely heavily on high quality training data, which can be incredibly difficult to obtain in the unique and complex underwater environment. The scarcity of annotated sonar data sets from real maritime missions means that advanced data augmentation techniques are crucial to develop effective and reliable AI models. To conclude, AI is not just a tool, its transformative force reshaping every aspect of submarine operations, from military combat to scientific discovery and commercial efficiency. While challenges remain, the future of underwater exploration and defense will undoubtedly be defined by the continuous integration of advancements of AI. That's all we had for today. Thank you for watching. Like, share, subscribe, and let us know what you think in the comments below.